Hey everybody, today we're going to be proving the half-angle identities for sine, cosine, and tangent. So let's start off with the half-angle identity for cosine. So let's begin with the double-angle identity for cosine. So we proved this in another Understanding Not Memorizing video. So cosine of 2 theta is just cosine squared of theta minus sine squared of theta. Please see that video if you don't understand how I got this. And so what's quite interesting about the half-angle identities is that it's literally the exact same thing as the double-angle identities, except they're just slightly rewritten. How so? Well, let's say we let, I don't know, x, we'll do that later. Let's first rewrite this double-angle identity, right, in just terms of cosine. So how will we do that? Well, we know that sine squared of theta is just 1 minus cosine squared of theta. So we can rewrite this as cosine squared of theta minus 1 minus cosine squared of theta, because that's the same as sine squared of theta from the Pythagorean identity. So that this will just be cosine squared of theta minus 1 plus cosine squared of theta. And then that'll just be 2 cosine squared of theta minus 1. So we have cosine of 2 theta equals to 2 cosine squared of theta minus 1. So let's let x equal to 2 theta. Then if we divide by 2 on both sides, we get theta equals x over 2. So let's plug that in here. So here we'll just get cosine of x equals to 2 cosine squared of, then this will then be x over 2 minus 1. So now we should kind of isolate this cosine, this cosine of x over 2, because that's, half angle. So let's move this 1 to the other side. So then this will then be 2 cosine squared of x over 2 equals to cosine of x plus 1. Cosine squared of x over 2 equals cosine of x plus 1 over 2. Then cosine of x over 2 is just plus or minus the square root of cosine of x plus 1 over 2. And so now let's do it for sine. So remember, cosine of 2 theta equals cosine squared of theta minus sine squared of theta. So then I want to get this side in terms of sine squared. So we can rewrite this as 1 minus sine squared of theta, because from the Pythagorean identities, cosine squared of theta is just the same as 1 minus sine squared of theta. So then we'll have 1 minus sine squared of theta minus sine squared of theta. And then this will then be 1 minus 2 sine squared of theta. And so then cosine of 2 theta is just 1 minus 2 sine squared of theta. So same thing, let's let x equal to theta. Then theta is just x over 2. Plug that in. We get 2 times x over 2 is just x. So again, cosine of x is just 1 minus 2 sine squared of then x over 2. Want to isolate this sine of x over 2. So then we get, move this 1 to the other side. So then we get cosine, or let me write this here, negative 2 sine squared of x over 2 is just cosine of x minus 1, right? And then divide by negative 2 on both sides, we get sine squared of x over 2 is just cosine of x minus 1 over negative 2. And then we take square root of both sides, so we get sine of x over 2 is just plus or minus the square root of cosine of x minus 1 over negative 2. So we can then, of course, rewrite this as plus or minus the square root of we can put a negative outside here, negative of 1 minus cosine of x over negative 2. These will then cancel. So then we get plus or minus the square root of 1 minus cosine of x over 2. And so now if we want to get tangent of x over 2, tangent of x over 2 is just then using our quotient identities. This will just be sine of x over 2 over cosine of x over 2. And we just proved those. So then this will be plus or minus the square root of 1 minus cosine of x over 2 over plus or minus the square root of, you can use this here, cosine of x plus 1 over 2. And so if we think about the plus or minus here, right, if we think about plus or minus over plus or minus, we have plus over plus, plus over minus, minus over plus, and minus over minus. So then these will just be plus, plus, minus, minus. So we're just going to end up with another plus or minus. So it'll be plus or minus the square root, and then we can put this all under the radical here. 1 minus cosine of x over 2 over cosine of x plus 1 over 2. We see that these will cancel. Let me write this here. These will cancel, and then we get plus or minus the square root of 1 minus cosine of x, and then we can rewrite this as 1 plus cosine of x. And then this should